Alright guys, so let's review for exam 1, okay? So before we get into details, I'll just structure about the exam 1. We'll have multiple choice question. Questions on Moodle. Okay, so maybe I'll write topic here, exam 1. Questions, multiple choice questions on Moodle. Does it mean you won't have any problem? No, you have a problem, but you are going to select only the correct answer. Okay, so whatever the problem you get in the exam, you have to do it in your notebook. Make sure just don't randomly pick up the choices. Let's say A, B, C, 3 choices. Don't just pick it up. You have to do actual process, like all these steps to come to the answer. Okay, and then only go and pick the correct answers. So all questions are going to be multiple choice format, but then they will need a significant steps for you to arrive at the answer. So if you have been doing, practicing questions that we did in the lecture, as well as if you have been, doing working homework problems, you should be totally fine. Is it synchronized or asynchronized? I'm going to leave it as asynchronized. So multiple choice. So asynchronous. Then again, this is when I say asynchronous, please, I have this trust on you that you don't share whatever you do in the exam with another person. Okay, this is very important, right? And so make sure it's for your own good also, right? Like you want to master this skill, not just do it without knowing what you are doing. So asynchronous. So make sure you don't talk about the exam to anyone at least until next Tuesday, because I may have 1 or 2 students who may not be able to work during that exam day, or at least during that 24 hours or so. So please just do your exam. After you are done with the exam, just don't talk to anybody, and then so please keep that privacy about the exam questions. Asynchronous, but it will be timed. It will be timed. So it will be like in the quiz format in the Moodle. Okay, so it may not say exam, but it will be probably like it will be in the quiz format. So you just pick the answer. So you have a certain duration, some duration to finish. Duration to finish the exam. Of course, this is exam you can attempt only once. Another thing is, I will leave this quiz open for 24 hours. Maybe not 24 hours, let us say Thursday. Okay, let me leave this open for 24 hours. I'll leave this window open for 24 hours, but you have to do it during that time. So let's say, next Thursday I open it exactly at the time we start our lecture class. If you have, set up your schedule in different way, because this has been a synchronized lecture, and you want to do the exam sometime tomorrow, so make sure you finish it by tomorrow. If I do it like today, if I were to leave it today at 11:20 a.m., you want to make sure you finish it by tomorrow 11:20 a.m. Okay, so any time during today and tomorrow, you should be able to do that. That is because some of you are not in the same time zone, so that should help you guys out. I don't want you guys to be writing exam at 3 o'clock in the morning. No, I don't want that. But it's timed, so meaning it doesn't matter when you are writing this exam, you have to do at a first attempt. So you cannot start today, do a little bit, and then do it in a couple of hours. No, if you start, you just finish it. That's how it is. Okay. So that is it about the structure. All right, so let's look at a few things. Alright guys, so for exam 1 I have this sheet of equation. Sheet with equations. For exam 1, really, I mean, this is already, you have seen these equations, okay, already in the lecture. So if you have been, taking a good notes, you should be fine. But then, even if you haven't been taking notes, make sure please you go back and then look through these. Just looking at the equation won't help you. You have to actually work out the problem. I'll also post this equation on Moodle today, so you should have access, okay, beforehand. So looking at the equation, we have, from pressure and fluids, you should be able to be familiar with the, density of, how to determine the density of an object, okay? Our density of a fluid here, and then you should also be able to define and then find a pressure. There is also equation about hydrostatic pressure. So if you remember how to find the pressure at the depth h for a liquid, you should be able to use the equation P equal to, P2 equal to P1 plus rho GH, where rho is the density of the fluid, h is the depth of the fluid. Make sure you are familiar with, familiar and comfortable working out the problems related to Archimedes' principle, which says the weight of the buoyant force is equal to weight of the fluid displaced, and then also weight of the floating object if the object is floating, right? There is also a continuity equation, Q, remember? Q equal to what? A area, cross-sectional area, times B is the speed of the fluid through that cross-sectional area, right? So that Q equal to AV, volume flow rate is constant in a given tube. And of course the Bernoulli's equation, which is really another form of conservation of energy for a fluid in motion, okay? So that's from the fluid chapter. For oscillation chapter, make sure you are familiar and comfortable with describing the position of the object under simple harmonic motion. So you should be able to, work out problem related to the position versus time of the object under oscillation, velocity versus time of the object under oscillation, and acceleration versus time of the object under oscillation. So make sure you have, make sure you look at the problems that we did in the lecture, and as well as a homework problem that I'm going to put it later today. Mass is spring system. For mass is spring system, you guys are already familiar, right? Like the restoring force is equal to what? Minus K means spring constant times the change in the length of the spring, which is x, right? So F equal to minus kx. Energy of the spring mass system, E is given as the sum of the total energy of the system is given as total kinetic energy plus total potential energy. So E equal to U plus K, half kx square plus half mv square. F equal to 1 over 2 pi square root of k by m, so where f is the frequency, right? So you can also determine the frequency of oscillation of a spring mass system using the two things. One is the spring constant, another is the mass. Simple pendulum, we can also determine the frequency of simple pendulum. Remember, frequency is given, here f equal to 1 over 2 pi square root of g by l, where g is the free fall acceleration, l is the length of the simple pendulum. A physical pendulum, this is something we just looked at it today. Frequency of physical pendulum is given as f equal to 1 over 2 pi square root of m times g times d by I, where d is the distance from the pivot point or pivot point to the center of the gravity. I is the moment of inertia of the physical pendulum. We looked at a damp oscillation, right? Today, in the last lecture, and we reviewed about it today. Damp oscillations, you can describe the position versus time using this mathematical model where xt equal to ae to the power minus t by tau cos 2 pi ft. So you may not be able to see it here in the video, but you guys have this equation, right? And then we talk about what is the tau. Tau is the time constant, or also called as characteristic time characteristic time of the decay of the oscillations, right? And then there are some numerical constant. P atm, atmospheric pressure, is equal to 1.013 times 10 to the power 5 Pascal. Density of water is 1000 kg per meter cube. Other information you should have it sufficient just in the exam equation, or exam questions itself. Okay, so these are the equations you have. I'm going to put this in Moodle, so you should have it early access. Make sure you print out or have a copy of it somewhere when you are, have it ready before you start your exam. Okay guys, so let us review a problem here. So I'm going to write this question here and then let you guys work for some time. Question 1. What is the pressure inside the chamber labeled, I can use this one else. Sorry about that. I wanted to write one L, not two. Labeled PM assume the right tube is open to the atmosphere and that I'm gonna use this part and write it here, okay? Tube is, and that the fluid in the tube is mercury, and density of mercury, rho Hg, is given as, Hg means mercury, okay, 13,600 kg per meter cube. Alright, so this is the question here. I'm going to draw a diagram over here. It's going to be a little bit congested, but I think it should be okay. So you gotta, let's have it something like this. Up. Okay, so this here, this is where we have level PM, so that's the gas we have there. There are there is mercury inside this. This is mercury, okay? Here, and then this is, let's call, rho Hg, okay? I'm just writing it here. Mercury of density, rho Hg. And then this is not just up there, it's actually up somewhere up to here. So there is this height here. This height is 20 centimeter. 20 centimeter, okay? So this height is 20 centimeter, and then this is open to the atmospheric pressure here, okay? So what is the pressure inside the chamber? Level PM. So what is the pressure here? Assume the right tube is open to the atmosphere. So the right side, this one is open to the atmosphere here. So let's write this as P-ATM, okay, or P naught. Atmosphere, and that the fluid in the tube is mercury. So this is mercury here, and it has this density. So how do we find the pressure here, guys? So I'm gonna let you guys work on this. So please take another, I don't know, 4 or 5 minutes. Try to work on this. You guys have already, I hope you have already done this in your homework as well. So please work on this and then see whether you are able to do it or not. And then of course I'll help you guys out after some time, after you guys working it on your own. Alright, so please take another 5 minutes or so to work on this.